FF4 Euro HPC is the successor to the prior Fortissimo projects. It successfully demonstrates the business benefits of using high-performance computing, artificial intelligence, machine learning, and high-performance data analytics technologies for business in diverse industrial sectors such as manufacturing, healthcare, energy, e-commerce, environment transportation, engineering, and aeronautics. Each productively concluded experiment generates a success story with the intent to inspire HPC uptake in related industrial communities. We are presenting the FF4 Euro HPC success story entitled Boosting Computational Fluid Dynamics Simulation of Thermal Equipment for Food Processing. This success story was produced in collaboration with the Spanish National Competence Center for HPC. In this experiment, a specialized computational fluid dynamics tool was developed to help SME Takare to optimize the design of thermal sterilization equipment. Takare designs and manufactures solutions, being specialized as a machinery supplier for fish canning factories. It has supplied solutions worldwide, and its portfolio involves thermal processes, sterilizers, vacuum pre-cookers, to robot cellules adapted to canning processes to automate complete production lines in all possible food sector factories. In canned food processing, thermal treatment supplied in autoclaves for product sterilization are among the most energy-demanding processes. The pressure for reducing energy consumption is a business challenge for the manufacturers of thermal treatment machines and the customers using those machines. Meeting that challenge would also lead to reduction of CO2 emissions in the environment.
The existing commercial simulation tools in the market adopt a generic approach, which makes the representation of various geometries and operating conditions time-consuming and consequently costly to use for testing, and requires highly skilled and specialized personnel well-versed in these methodologies. Therefore, the challenge is to develop a specialized tool focused on simulating thermal sterilization processes in autoclaves.
The partners in this experiment developed a computational fluid dynamics simulation tool focused on simulating thermal sterilization processes in autoclaves. This tool will stand out for its ease of use and user support, which will eliminate the need for general calculation tools and personnel highly qualified in thermal simulations.
The tool is a complete software as a service, including the high-performance computing resources, and is offered to customers as a subscription with all services included. The solution consists mainly of two parts: the simulation model, developed using OpenFOAM and executed on the HPC platform, and the web GUI interface. The use of high-performance computing allows Takare and end users of autoclaves to carry out simulations in more detail and in less time, enabling users to test different cases in a short time.
Takare will have a market advantage with more efficient and customizable manufacturing. The cost reduction to develop an autoclave will facilitate the substitution of obsolete equipment, leading to yearly savings of €40,000. Furthermore, Takare estimates a reduction in production costs of around 23% of the autoclave price, representing an annual benefit equivalent to approximately 3% of the average annual revenue. The experiment simulations and analysis will provide detailed information on a machine's energy consumption and detect if it is possible and worthwhile to intervene to reduce it, achieving a smaller carbon footprint.
This is also an opportunity to offer the new tool to other industries that apply this new service in their production processes and will face a business benefit in terms of their energy savings and reduction of CO2 emissions. These opportunities involve the incorporation of a specialized profile for the development and support of software as a service.
This tool can also be presented to students as a showcase for possible energy optimization applications. They can use the new instrument for academic activities and the knowledge acquired about high-performance computing and autoclave thermal processes to gain knowledge about CO2 emission savings. With saving costs and energy for food companies, an improvement in efficiency would also mean a reduction in CO2 emissions. FF4 Euro HPC. SME innovation through HPC. Get inspired. Visit www.ff4eurohpc.eu.